So the really important thing to know about projections is how they distort the data. Projection distortion is extremely important. There's a video here from Esri that talks about it. I like this little website because it shows you how things are distorted. In other words, here's the United States, and this is Mercator, which we'll talk about in a second. Google Mercator or Web Mercator, there's different names for it. But you can see that it massively distorts when we get near the poles, especially Antarctica is not this big. So it's not a good method to show the entire world with. And in fact, here's the United States. Well, here's the United States shown projected near the equator, so with less distortion, and it fits inside of Africa. If we go ahead and do Greenland, there's Greenland. And if you look at this, you might think, hey, Greenland is about the same size as Africa. Well, no, that's the projection. If we drag this down, you can actually put 10 Greenlands inside of Africa. China looks larger than it is. It's not really much bigger than the United States. Okay, and you can put the United States, India, and China all inside of Africa. Africa is a very large continent. Russia is another one. You look at this map and you go, wow, Russia is just huge. Well, actually, if we drag it down to the equator, this is a more accurate representation of its size. Suddenly it's not as big. The reason it looks so big on most maps is because of the projection and the distortion associated with them. Okay. Moving back. There we go. So play with that tool, and then here we come to Albers conic equal area. So this is one that's used heavily for representing the United States. This one is specifically for maintaining area. And within distortion, there's 3 different types of distortion that we get with different projection methods. We get them in different amounts. So here we've got an illustration for the tool you'll be using this week that I created that shows the distortion in distance along the meridians and parallels, or the lines of latitude and longitude. So you can see that here it does pretty well with distance, but as soon as you move down to the poles, especially the parallels are really getting stretched out, massively distorted. This is an illustration of the distortion of area. Green is goods, very little distortion area. However, take a look at what's happening with Antarctica. It is just getting distorted completely out of proportion, but area is maintained, so there's a trade-off between area and distance. Similarly, we have the conformal, or the shape of things. And Albers equal area actually does a pretty good job maintaining the shape using this tool, but that's because the tool just looks at the corners, the lat-long corners, to see if they're staying near 90 degrees. Okay, so these 3 different types of distortion we'll be looking at. Web Mercator, again, or Google Mercator, both names are used. When you get out down above about 85 degrees of latitude, it just really distorts radically. So not good for views of the entire Earth. And the tool we'll be looking at shows, again, this for distance. Works well at the equator. Area works well at the equator. Distance and area not so good above the and below the equator. But the shape is actually maintained. Like shape of Greenland is kind of close. Shape of Antarctica, not so much, but that's because it's looked at as a sphere. Okay, and we covered this in the other tool. You can see here Greenland, Africa, about the same size on this map, when in reality Greenland is 1/10 the size of Africa. And just another illustration that shows as we take the Earth, okay, these degree segments, which are equal, now become distorted when we project them. It's all about projection distortion. Okay, this is a little tool that I created that allows us to take a look at what happens when we project. So here I'm using cylindrical projection, and you can see the Earth, the sphere, being converted to a cylinder and then being flattened out. If you take a look at what's happening near the equator, there's not much distortion, right? Africa, Central America, India looking pretty good. However, if you take a look at the poles, the North Pole and the South Pole are just massively distorted, stretched out, beyond anything that would be recognizable. When we do a conic, Okay, then we project out into a cone. So now we have a cone, and then we flatten the cone out. Conics are good for mid-latitudes, like the United States, continental United States. As we project out, it stays fairly close to the same shape and size, but again, the poles are radically distorted. For planar, planar is when we take the Earth and we flatten it out into a plane. Okay, we just squish it. And those work well for one pole at a time, or really any small area on the surface of the Earth. There you go, planar projection. See how the North Pole does not change a lot. Okay,